Alright, in this problem, you're given the mass of cart 2, the velocity of cart 1 before collision, the velocity of cart 2 before the collision, and you're given the velocity of the combined carts. And you're being asked to find the mass of the combined carts and the mass of cart 1. And unlike the other two problems, there's no direct way to just see what the momentum is either before or after the collision. In the other two problems, we started with, alright, the momentum after is always going to equal the momentum before. But right now there's no two numbers we can multiply to figure out what the momentum is. So you have to set the problem up and be a little bit more deliberate when you solve it. Still going to be able to solve it. You just have to set the problem up. So remember that the formula for the conservation of momentum tells us the mass of object 1 times the velocity of object 1 plus the mass of object 2 times the velocity of object 2 is going to equal the mass of object 1 plus the mass of object 2 times the final velocity if it is an inelastic collision, which this is. So the collision, the carts are going to collide, stick together, and move off together. And of course these are before collision, and this side is after the collision. So let's fill in what we know. We don't know the mass of cart 1, so that's just m1, but we do know its velocity was 2 meters per second. And we know the mass of cart 2 is 0.8 kilograms, and we know its velocity was 0 meters per second. And then over here we don't know, again, we don't know m1, so we have to write m1 plus, but we know m2, 0.8 kilograms, and we know the final velocity as they're moving off together, 1.2 meters per second. Now if you look at this problem, at first you're like, well, how can I solve it? I have two unknowns, but you don't. It's the same unknown on both sides. So you can absolutely solve this problem because you have the equality of knowing that the momentum before equals the momentum after. So let's just crunch this out and see what happens. First of all, 0.8 times 8 is 0, and I can't do much else with that because I have that variable there. So I'm just going to rewrite it. m1 times 2 meters per second. It's kind of messy, so I'm going to put it in parentheses like that. Equals, and again, not writing anything there because times 0 means 0. Distribute the 1.2 here to both of these and you get 1.2 meters per second times m1 plus, and then 1.2 times 0.8 is 0.96, and then you get kilogram meters per second. Alright, and from here, now it's starting to look a little like something we might be able to solve. We need to get the m1s both on the same side. So this is being added to this, so I'm going to have to subtract it from both sides. And 2 minus 1.2 is 0.8. So I'm going to end up with m1 times 0.8 meters per second equals 0.96 kilogram meters per second. And now I can solve for m1 just by dividing both sides by 0.8 meters per second. 0.8 meters per second. Cancels out there, leaving us with m1 equals 0.96 divided by 0.8, which, put it into your calculator if you can't do that in your head. I know I can't. So 0.96 divided by 0.8, and you get 1.2. The meters per second cancel, leaving you with the units you want, kilograms. So the mass of cart 1 is 1.2 kilograms. And then the mass of the combined carts is just cart 1 plus cart 2, which works out to an even 2.0 kilograms. And that's how you use conservation of mass to solve that problem.